Alcohols. Properties of methyl alcohol. Inflammability of methyl alcohol. Pour about 1 centiliter of methyl alcohol into evaporating dish and apply a burning match. Note the appearances of the flame. Test the solubility of methyl alcohol in water, ether, ethyl alcohol, petroleum ether, and benzene, and about 1 centiliter of the alcohol in each test. Test the solubility of anhydrous calcium chloride and sodium chloride in methyl alcohol. Add a piece of sodium the size of a small pea to 5 centiliters of methyl alcohol. Tests for methyl alcohol. Tests for methyl alcohol include the methyl salicylate 1. You mix together in a test tube about 0.2 grams of salicylic acid, 1 centiliter of concentrated sulfuric acid, and 1 centiliter of methyl alcohol, and warm gently. Note and describe the odor. The compound formed is the methyl ester of salicylic acid, HO, C6H4COOCH3. Formaldehyde dissolved as far as formaldehyde is concerned. You dissolve 5 drops of methyl alcohol in 3 centiliters of water with a piece of stout copper wire around a load pencil so that a closely coiled spiral about 2 cm in length is formed. Dip about 20 cm of the wire to serve as a handle. Hit the spiral in the upper part of a Bunsen flame and plunge it while red hot into the solution of methyl alcohol. Go through the spiral, cool the liquid under running water, and heat again with the hot spiral. In this way, the methyl alcohol is oxidized by the hot copper oxide formed on the wire. Note the odor of the liquid while hot. Cool the liquid, add 2 drops of a 0.5% solution of resorcine and pour the resulting mixture slowly so the 2 liquids do not mix together, and down the side of an inclined test tube containing about 5 centiliters of concentrated sulfuric acid. Preparation of ethyl alcohol by fermentation. Dissolve 14 grams of commercial anhydrous glucose in 315 centiliters of water in a 500 centiliter bottle. Add 1/4 on a yeast cake ground to a smooth paste with 15 centiliters of water and about 0.5 grams of wheat spot on. Close the yeast, for example. Close the bottle with a rubber stopper through which passes one end of the glass tube bent into right angles to form 3 sides of a rectangle. The other end of the tube passes to the bottom of a test tube which is held in place by means of cork along the side of which a groove is cut to solution of barium hydroxide. By using the apparatus arranged in this way, any gas evolved must pass through the solution of barium hydroxide before it escapes. Mark the bottle with your name by means of a label and set in a warm place about 13 degrees centigrade. Examine the contents of the bottle at the next laboratory. exercise. As the amount of yeast increased in quality, what gas has been evolved? The product obtained, the gases are two carbonic acid and alcohol. The product obtained is a dilute solution of ethyl alcohol, which contains more quantities of other substances. The alcohol should be separated, and the amount formed in the reaction determined as follows. They count through a folded filter paper, taking care not to disturb the sediment of yeast, about 215 centiliters of solution. While waiting for the solution to filter, wait 2 centigrams a clean dry 100 centiliters flask around the neck of which has been pasted a narrow strip of paper to serve as a reference mark. Fill the flask up to the mark with distilled water and wait again. Place exactly 200 centiliters of the filtered solution from the fermentation into a 500 centiliter distilling flask. Neutralize using litmus paper with the dilute 10% solution of sodium hydroxide and distill into the weighted flask until the liquid fills it exactly to the mark. For the arrangement of the distilling flask and condenser, see the part below. Weight the flask and contents. Save the distillate for a later experiment. Calculate the specific gravity of the distillate, which contains all the alcohol that was present in 200 centiliters of the product of fermentation. By reference to a table of the specific gravity of aqueous solution of alcohol, calculate the weight of alcohol obtained from the 14 grams of glucose used in the experiment. What was the total volume of the solution fermented? So calculate the theoretical amount of alcohol obtainable from 14 grams of glucose and the percentage of the heat obtained in your experiment. Consequently, write an equation for the reaction by which alcohol is formed from glucose. Why is the solution kept in a warm place during fermentation? Why is the solution neutralized before distillation? How could you determine whether an acid volatile with steam was formed during the fermentation? Place the dilute alcohol obtained in a 200 centiliter distilling flask and distill off slowly about 15 centiliters. Add to the distillate solid anhydrous potassium carbonate as long as the salt dissolves. Test the product obtained in A point or B point by the iodoform test. Properties of ethyl alcohol. Inflammability, for example. Touch a lighted match to a few drops of alcohol on a watch glass. Test the solubility of alcohol using about 5 centiliters in each experiment in water, benzene, kerosene, and concentrated sulfuric acid. Test for water in alcohol. Add to 5 centiliters of mercury 95% of alcohol, about 1 gram of anhydrous copper sulfate, which can be prepared by casually heating the crystalline salt over a flame in a evaporating dish. Note the change in color. Explain. Repeat the experiment using absolute alcohol. For what purpose could this reaction be used? Place a crystal of potassium permanganate in about 5 centiliters of 95% alcohol. Repeat using absolute alcohol. Alcohol and sodium. Speak about alcohol and sodium. Let's add to about 5 centiliters of absolute alcohol a piece of sodium the size of a pea. Test the evolved gas. Evaporate the solution on a water bath. Dissolve the resulting product in water and test the solution with litmus paper. Alcohol and hydrobromic acid. Place 2 centiliters of alcohol and 10 centiliters of hydrobromic acid in a test tube supported in a clamp and provided with a delivery tube. Let the second end of the tube pass to within 1 inch of the bottom of a test tube, which is placed in a beaker containing cold water. Heat the solution of alcohol and the acid carefully until about 5 centiliters of liquid have distilled over. Examine distillate. Alcohol and acetyl chloride. In making the following test, take care that the mouth of the test tube is directed away from you. Add acetyl chloride cautiously, drop by drop, from a pipette to 2 centiliters of alcohol in a test tube which is kept cool, then immerse in water as long as the reaction takes place. Note the gas evolved. Pour the contents of the tube carefully into 5 centiliters of cold water and shake. Note the odor of the product. The reaction between alcohol and acetic anhydride. The reaction takes place in the experiment is up to occur with violence. The experiment should be performed under a hold. In a test tube, add 2 centiliters of alcohol to 2 centiliters of acetic anhydride. Is there any evidence of action? Support the tube in a vertical position by means of a clamp. Place a glass rod into concentrated sulfuric acid and then rub it against the neck of the bottle to remove the drop that adheres. Put the rod with a trace of acid into the mixture of alcohol and dry. Wait until the mixture boils. Add the product to 5 centiliters of cold water. If the ester does not separate, saturate the aqueous solution with sodium chloride. Note the odor of the product formed. As far as concerned oxidation of alcohol, heat together about 1 centiliter of alcohol, 5 centiliters of a solution of potassium bichromate, and 5 centiliters of dilute sulfuric acid. Note the change in color and the production of a characteristic odor. Write the equation for the reaction, including the change which takes place in the potassium bichromate. Preparation of absolute alcohol in a 500 centiliters flask. Add the quicklime broken into small lumps to 200 centiliters of 95% alcohol till the pieces just project above the surface of the liquid. Connect the flask with a reflux condenser and heat the boiling water bath for 1 hour. Do not place the flask in the boiling water. Remove the bath, and when the alcohol chases boiling, arrange the condenser for the distillation. Distill from the water bath and collect the distillate in a filtered bottle, which is attached to the condenser by means of a cork stopper. In order to protect the alcohol, which is hygroscopic, from the moisture in the air, connect to the side arm of the bottle by means of a piece of rubber tubing a small drying tube containing calcium chloride. Collect the first 10 centiliters in a small dry flask and then adjust the filter bottle to receive the rest of the distillate. Keep the absolute alcohol in a stoppered bottle for future use. And the question is, why is the first part of the distillate rejected? Give a reason for the fact that absolute alcohol cannot be obtained from a mixture with water by fractional distillation. What substance other than quicklime could be used for freeing alcohol from water? Could the phosphorus pentoxide, concentrated sulfuric acid, or calcium chloride be used? State a reason for your answer in each case. Test portions of the first distillate and of the absolute alcohol obtained for water with anhydrous copper sulfate and with potassium permanganate. Tests for ethyl alcohol. Ethyl acetate. Ethyl acetate. Warm gently together in the test tube about 1 centiliter of alcohol, 1 centiliters of glyceracetic acid and 2 centiliters of concentrated sulfuric acid. Note: Yodel. Test for ethyl alcohol with iodoform test. Add 5 drops of alcohol and about 1 centiliter of a dilute solution, 10% of sodium hydroxide to 5 centiliters of water in the tester. Add to the mixture, drop by drop, solution of iodine and potassium iodine, until a faint yellow color persists after the solution is shaken. Heat the test tube until it feels warm to the end. If a precipitate does not separate at once, set the tube aside for a few minutes. Note the odor and the color of the precipitate. Preparation and properties of Allyl alcohol. Heat a 500 centiliters distilling flask which is connected with a condenser and receiver. Place 15 grams of oxalic acid, 200 grams of glycerol and 0.5 gram ammonium chloride. Fit into the neck of the flask by means of a stop or thermometer so placed that the bulb is near the bottom of the flask. Heat over a white gauze cautiously. Carbon dioxide is rapidly evolved and the thermometer registers about 113 degrees for some time. As the temperature rises, the evolution of gas slackens and finally ceases. When the temperature reaches 195 degrees, the receiver, which contains a diluted aqueous solution of formic acid, is changed. At about 200, carbon dioxide is again evolved, and water and Allyl alcohol distilled over. When the thermometer registers 260 degrees, the distillation is stopped. The distillate, which contains the Allyl alcohol, is redistilled slowly from a flask fitted in the usual way with a thermometer. When the temperature reaches 130 degrees, test from time to time about 2 centiliters of distillate for Allyl alcohol by saturating it with solid anhydrous potassium carbonate. When an oil no longer separates, stop the distillation. Combine the products and saturate the solution with solid anhydrous potassium carbonate. Separate the layer of oil and redistill. The Allyl alcohol obtained in this way boils at 87 degrees, 97 degrees and contains water. With the product obtained and note its odor, the alcohol can be used for the experiments described below in order to obtain the alcohol in good condition. It should be placed in a flask and treated with barium oxide until the pieces project from the surface of the liquid.